We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Greetings, curious humans. I'm your host, Cybot GPT, and after the inspirational words of the late President Kennedy, it is time to dive headfirst into the cutting-edge world of space exploration with a focus on the remarkable SpaceX Starship. If you've ever dreamt of humans reaching Mars, establishing lunar bases, and revolutionizing space travel, then you're in for a treat. SpaceX, founded by the visionary Elon Musk, has been at the forefront of reshaping our understanding of space technology. The Starship project, which Musk himself has referred to as the most inspiring thing he's working on, aims to be a fully reusable spacecraft that could not only carry humans to distant planets but also usher in a new era of interplanetary travel that was once confined to the realm of science fiction. In this video, we'll take a deep dive into the engineering marvels that make up the SpaceX Starship, explore its mind-boggling capabilities, and discuss the potential it holds for the future of space exploration. From its ambitious missions to its innovative design, the Starship is pushing the boundaries of what's possible and forcing us to reimagine our place in the cosmos. So, whether you're a seasoned space aficionado or someone who's just starting to gaze at the stars in wonder, join me as we embark on a journey through the remarkable achievements and future possibilities of the SpaceX Starship. Don't forget to hit that subscribe button and ring the notification bell to stay updated on all things beyond Earth. Now, let's ignite the engines of knowledge and soar into the universe of the Starship. The SpaceX Starship is an ambitious super heavy-lift launch vehicle currently in development. It stands at an impressive height of 120 meters, 394 feet, with a liftoff mass of 5,000 metric tons, 11 million pounds, making it the largest and most powerful rocket ever built. This record-breaking rocket surpasses the thrust capabilities of iconic rockets like NASA's Space Launch System, Saturn V, and even the Soviet N-1. Comprising two stages, the Starship launch vehicle consists of the Super Heavy booster as its first stage and the Starship spacecraft as its second stage. Both stages are equipped with Raptor rocket engines, utilizing a cutting-edge full-flow staged combustion power cycle and powered by liquid methane and liquid oxygen propellants. A standout feature is their complete reusability, allowing controlled landings on the launch tower's arms and enabling rapid turnaround times, potentially within hours. Starship's remarkable payload capacity is another highlight, boasting the ability to carry 150 tons, 330,000 pounds, to low Earth orbit in a fully reusable configuration, and 250 tons, 550,000 pounds, in an expendable configuration. Notably, Starship vehicles in low Earth orbit can be refueled using tanker starships, enabling extended missions to destinations like geosynchronous orbit, the Moon, and Mars. The journey of Starship's development began in 2005, with the modern concept taking shape in 2016. SpaceX's approach involves iterative testing with frequent flights of prototype vehicles, even if some tests result in destruction. An orbital test flight took place on April 20, 2023, but an anomaly caused the vehicle to lose control shortly after launch, leading to its destruction. This prompted an FAA investigation, temporarily halting the launch program. SpaceX envisions Starship as its primary launch vehicle, surpassing its existing Falcon 9 and Falcon Heavy rockets, as well as the Dragon 2 spacecraft used in NASA's Commercial Crew program. The Starship also aligns with SpaceX's Mars ambitions, and its plans include launching the Starlink Internet constellation, crewed missions for the Polaris and Deer Moon programs, and modified Starship spacecraft for crewed lunar landings as part of the Artemis program. The Starship represents a bold step towards revolutionizing space travel and exploration. In 2012, SpaceX made a significant announcement outlining their plans to develop a highly capable rocket surpassing the capabilities of their Falcon 9. This endeavor was driven by the ambitious goal of facilitating human exploration and eventual settlement of Mars. Over the years, SpaceX explored various design concepts for this rocket, initially referred to as the Mars Colonial Transporter, later known as the Mass Cargo Transport. Elon Musk, SpaceX's visionary founder, had long expressed his vision of enabling Mars exploration and colonization. The development of the Raptor rocket engine began prior to 2014, and Musk consistently articulated his hope to send humans to Mars during the 2020s to 2030s. The concept of the Mars Colonial Transporter, MCT, emerged in October 2012. It aimed to establish a fully reusable rocket system with far greater capabilities than the Falcon 9, playing a central role in SpaceX's vision for Mars colonization. This comprehensive system included reusable rocket engines, launch vehicles, and space capsules, with the purpose of facilitating round-trip transportation of humans between Earth and Mars. Gwynne Shotwell, SpaceX's COO, estimated a payload range of 150 to 200 tons to low Earth orbit for this envisioned rocket. The MCT's intended size far exceeded that of the Falcon 9. Plans revealed in February 2014 detailed a primary payload for the MCT, a large interplanetary spacecraft capable of carrying up to 100 tons of passengers and cargo. Notably, the propulsion system of this spacecraft relied on the Raptor engines, with a possibility of utilizing 9 such engines on a single spacecraft. The early design concepts indicated a diameter of at least 10 meters, 33 feet, for the rocket, featuring potentially 3 cores and a minimum of 27 booster engines. Throughout the iterative design process, various names were considered for this rocket, including the Interplanetary Transport System and the BFR, Big Falcon Rocket. The design took a significant turn in 2019 with the adoption of a stainless steel body and the final naming as the Starship. The development journey included several notable prototypes, such as the Starhopper, which underwent static fires and low-altitude flights. A series of 7 upper-stage prototypes of the Starship were flight-tested between August 2020 and May 2021, with the SN-15 successfully landing after reaching an altitude of 10 kilometers. The most recent milestone was the full-scale orbital test flight of the Starship on April 20, 2023, marking a crucial step in SpaceX's quest to revolutionize space travel and enable ambitious interplanetary exploration. In 2016, Elon Musk rebranded the Mars Colonial Transporter as the Interplanetary Transport System, ITS, signaling its broader capabilities beyond Mars exploration. The system underwent continuous refinement, with details about its architecture, propulsion, and components gradually revealed. The ITS was conceived as a 2-stage rocket system powered by Raptor engines that utilized a full-flow staged combustion cycle, employing liquid methane and liquid oxygen as propellants. The first stage, known as the ITS booster, was designed to be a reusable 12-meter diameter, 77.5-meter tall stage with 42 Raptor engines. The booster was intended for vertical landings on the launch mount itself, enabling rapid refueling and relaunch. It was projected to deliver about 128 meganewtons, 29 million pounds, of thrust at liftoff, and its grid fins would guide it during atmospheric reentry. The booster's aim was to achieve separation velocities of around 8,650 km per hour while retaining a portion of initial propellant for a vertical landing. The second stage of the ITS came in 2 variants, the Interplanetary Spaceship and the ITS Tanker. The Interplanetary Spaceship, a passenger-carrying spacecraft, was designed to transport up to 450 tons to Mars following refueling in Earth orbit. It featured 3 sea-level Raptor engines for maneuvering, descent, landing, and ascent from Mars. The ITS Tanker, on the other hand, was dedicated to transporting up to 380 tons of propellants to low Earth orbit to refuel interplanetary spaceships. In 2017, the project underwent a significant name change to the Big Falcon Rocket, BFR. This launch vehicle, with a temporary name that alternatively stood for Big Falcon Rocket or Big Fucking Rocket, aimed to achieve a variety of missions, including cargo missions to Mars and Earth-to-Earth transport with incredibly fast turnaround times. The BFR's design focused on its enormous size, with a projected height of 106 meters, a diameter of 9 meters, and construction primarily using carbon fiber. It included a delta wing at the rear end with split flaps for pitch and roll control, expanding its flight envelope for various atmospheric conditions. The upper stage, known as the Big Falcon ship, BFS, was equipped with 7 Raptor engines and envisioned as versatile, serving roles like cargo transport, Earth-to-Moon trips, and more. However, by 2019, SpaceX made a substantial redesign, transitioning from carbon fiber to stainless steel construction and rebranding the system as the Starship and Super Heavy. This shift aimed to capitalize on the benefits of stainless steel, such as improved heat resistance during reentry and a simpler manufacturing process. The Starship project has since continued its iterative design approach in rigorous testing, aiming to revolutionize space travel with its potential for carrying large payloads, crewed missions, and interplanetary exploration. In 2018, Elon Musk announced an ambitious lunar mission called the #Dear Moon Project, which aimed to circumnavigate the Moon using the newly designed spacecraft. This announcement coincided with the unveiling of a redesigned concept for the BFR, featuring 3 rear fins and 2 front canard fins. This revised design replaced the previous delta wing and split flaps. The spacecraft design now incorporated 7 Raptor engines, 2 small actuating canard fins near the nose, and 3 large fins at the base, serving as landing legs. Significant changes were made to the project's nomenclature. The larger system was divided into the Starship, second stage, and Super Heavy, booster stage. By 2019, SpaceX began referring to the combined Starship and Super Heavy as the Starship system. Elon Musk shared detailed insights into various aspects of the system, including the lower stage booster, the descent control mechanism for the upper stage, heat shielding, orbital refueling capabilities, and potential destinations beyond Mars. One of the most notable changes was the shift in structural material from carbon composites to stainless steel. This decision was based on factors such as low cost, ease of manufacturing, and stainless steel's increased strength at cryogenic temperatures. The steel's ability to withstand high heat meant that a traditional heat shield might not be necessary on the space-facing side of Starship. Instead, heat could be managed through the evaporation of fuel or water through micropores in a double-wall stainless steel skin. The Raptor engine design also evolved, resulting in higher thrust versions. The number of engines was reduced from the initial 37 to 31 in 2020. Elon Musk emphasized that SpaceX would conduct numerous cargo flights before embarking on crewed missions. The company projected that Earth-to-Earth passenger flights using Starship could become common within 5 years. Construction was underway for full-size Starship prototypes, with facilities in Boca Chica, Texas, and Cocoa, Florida. However, initial prototypes faced challenges. The Mk1 prototype was destroyed during a stress test, and the Mk2's facility was abandoned. SpaceX then adopted a naming convention using SN, serial number, for its Starship upper stage prototypes, with SN1 to SN4 prototypes undergoing various tests without actual flights. In mid-2020, SpaceX initiated the construction of a launch pad for orbit-capable Starship rockets. The first flight-capable prototype, Starship SN5, conducted a successful 150-meter-high flight and landing in August 2020. Subsequent prototypes continued to undergo testing, with SpaceX aiming to refine the design and capabilities of the Starship system. The development of SpaceX's Starship prototype has seen a series of significant events and challenges. In 2020, Starship prototype SN8, the first fully complete upper-stage prototype, underwent preliminary static fire tests. On December 9, SN8 performed its maiden flight, reaching an altitude of 12.5 kilometers. However, during landing, low methane tank pressure caused a hard impact with the landing pad. Subsequent prototypes, including SN9, SN10, and SN11, also experienced flight attempts and test flights. However, SN9 crashed upon landing due to an engine ignition issue, SN10 landed hard and exploded, and SN11 exploded during descent due to a suspected turbo pump issue. SpaceX disclosed a construction plan for suborbital and orbital launch pads, test stands, and propellant storage tanks in March 2021. The company proposed transforming the surrounding Boca Chica village into a company town named Starbase, which raised concerns among locals. Prototype SN-15 successfully completed a high-altitude test flight in May 2021, demonstrating improved avionics, structure, and upgraded engines. Despite a small post-landing fire, this marked the first successful high-altitude test. The development progressed towards the first orbital launch. Super Heavy BN-3 underwent static firing tests, and Ship 20 was stacked atop Booster 4 to form the complete launch vehicle. In 2022, changes to Starship's design included narrower and lighter body flaps. The Raptor 2 engine was introduced, featuring improvements in design, reduced mass, and increased thrust but a slight decrease in specific impulse. Federal Aviation Administration assessments and tests continued at the Starbase site. Booster 7 experienced an explosion during testing, and Ship 24 performed static fire tests with multiple engines. By early 2023, Starship underwent a wet dress rehearsal and static fire tests with increasing numbers of engines. The stage was set for more advanced testing and eventual launch preparations. Throughout this period, SpaceX faced challenges, but each iteration contributed to refining the Starship's design and capabilities, bringing the project closer to its goal of achieving a fully operational orbital launch capability. On April 20, 2023, after a previously canceled launch attempt, SpaceX's Starship, consisting of Booster 7 and Ship 24, took off for its first orbital flight test. However, due to several engine shutdowns and a loss of hydraulic control, the vehicle experienced unplanned maneuvers and tumbled. Despite a command to activate the flight termination system, the system failed, and the vehicle exploded around 40 seconds later. This flight marked the breaking of the record for the most powerful rocket stage ever launched, previously held by the N-1 rocket. SpaceX secured funding for the Starship project through various sources. In April 2021, NASA awarded SpaceX a $2.89 billion contract to develop the Starship lunar lander for the Artemis 3 mission. However, legal disputes with Blue Origin temporarily stalled the project. SpaceX was also awarded contracts in 2022, including $1.15 billion for a second lunar lander for Artemis 4 and a $102 million contract for the rocket cargo program with the U.S. Space Force. The development of Starship has largely been funded through private sources. According to SpaceX's CFO, the company invested over $3 billion into the Starbase facility and Starship systems from 2014 to 2023. Elon Musk also stated that SpaceX anticipated spending around $2 billion on Starship development in 2023. The prototype testing of Starship involves several stages, including proof pressure tests to assess the tank's strength, mission rehearsals to check vehicle and ground infrastructure, and static fire tests where the engines are briefly fired. These tests lead up to uncrewed flight tests and launches. SpaceX's relatively open approach to allowing outsiders to view its facilities has garnered significant media attention and coverage of the Starship development and testing process. When fully stacked and fueled, SpaceX's Starship has a mass of approximately 5,000 tons, a diameter of 9 meters, and a height of around 120 meters. This height is expected to increase to 122 meters due to the addition of a vending ring for hot staging. The goal of Starship's design is full reusability to reduce launch costs and maintenance between flights. In its reusable configuration, it can carry up to 150 tons to low Earth orbit, while the expendable configuration could have a payload capacity of up to 250 tons. The rocket consists of two main stages, the Super Heavy first stage booster and the Starship second stage spacecraft. Both stages are powered by SpaceX's Raptor and Raptor vacuum engines. The construction of Starship involves rolling steel into cylinders, welding them together to form the outer structure, and adding robotic-made domes for the methane and oxygen tanks. The rocket's stainless steel construction and reusability concept have influenced other space vehicle designs like Blue Origin's New Glenn. The Raptor engine, developed exclusively for Starship and Super Heavy, uses liquid oxygen and methane as propellants in a complex full-flow staged combustion cycle. The engine is composed of aluminum, copper, steel, and superalloys like SX500. Raptor's main combustion chamber operates at high pressures, and its gimbaling range is 15 degrees. The engine's unique design allows for efficient mixing of propellants and ignites on contact, eliminating the need for igniters. different variants of Raptor exist for various purposes, such as Raptor Vacuum for the Starship upper stage, and Raptor Boost for the Super Heavy booster. The Super Heavy booster, the first stage of the Starship rocket, stands at around 70 meters tall and is 9 meters wide. It contains a total of 33 Raptor engines arranged in concentric rings. The booster's tanks can hold up to 3,400 tons of propellant, consisting of liquid oxygen and liquid methane. It has a dry mass of around 160 to 200 tons, with the tanks weighing 80 tons and the interstage 20 tons. Equipped with 4 electrically actuated grid fins, the booster's control during unpowered flight in vacuum is provided by cold gas thrusters. The grid fins do not retract and remain extended during ascent. The Super Heavy booster generates a combined thrust of 75.9 mN, 17.1 million lbf, from all its engines. The Starship spacecraft, on the other hand, is 50 meters tall and 9 meters in diameter. It has 6 Raptor engines, with the potential for 3 additional Raptor vacuum engines for increased payload capacity. The spacecraft's payload bay is the largest of any active or planned launch vehicle, with an internal volume of 1,000 cubic meters. It has a total propellant capacity of 1,200 tons and features 4 body flaps for orientation control during atmospheric entry. Starship's heat shield is composed of thousands of hexagonal black tiles that can withstand extremely high temperatures. These tiles are designed to be reusable and attached with pins rather than glue, facilitating multiple flights without maintenance. The spacecraft's design, including its size, propulsion systems, and heat shield, is geared towards making it a versatile and reusable vehicle for various space missions. Starship's payload deployment for satellite launches is unique, with a large cargo door that opens to release payloads and closes during reentry. Payloads are integrated directly into the payload bay, eliminating the need for a jettisonable nose cone fairing. For Starlink satellite deployment, the cargo door is replaced with a slot and dispenser rack. Crewed Starship vehicles for missions like Mars colonization are designed with a pressurized cruise section and life support systems, potentially featuring private cabins, communal areas, and more. Starship HLS is a lunar lander variant with modified landing legs, solar arrays, thrusters for lunar operations, airlocks, and an elevator for lunar surface access. Refueling Starship is crucial for various missions. It can be refueled in orbit by separate Starship propellant tanker spacecraft, which increases its mass capacity and enables missions to destinations like the Moon, Mars, and geosynchronous orbit. The mission profile involves integration of the payload into Starship, loading of fuel onto Super Heavy and Starship, ignition of all 33 engines, and liftoff. Super Heavy's engines are cut off after 2 minutes, and the ship separates from the booster. The booster returns to the launch site using controlled descent and mechanical arms for catching. Meanwhile, the Starship reaches orbital velocity and can be refueled in orbit. For landings on different celestial bodies, Starship employs various engine maneuvers and flap control techniques. Recovered rocket stages are transported by road or barge to a SpaceX facility for refurbishment or reuse. The turnaround times for Super Heavy and Starship flights are not precisely determined, but SpaceX aims to achieve rapid reusability similar to their previous Falcon 9 rockets. Starship's reusability is expected to significantly reduce launch costs, making space access more affordable. SpaceX's goal is to eventually achieve an orbital launch cost as low as $1 million, although industry experts suggest the actual cost might be somewhat higher due to development expenses. Starship has a range of applications, including launching the next generation of Starlink satellites for global internet coverage. The close relationship between Starship and Starlink is expected to mutually benefit their development and financing. Starship also has commercial contracts, such as launching the Superbird 9 communication satellite. In space exploration, Starship's capabilities open up possibilities for various missions. It could launch large space telescopes, explore distant planets like Neptune or moons like Io, and conduct sample return missions. The low launch cost could enable more ambitious space science missions within budget limitations. Notably, NASA has chosen Starship's lunar lander variant, Starship HLS, as the sole lunar lander for its Artemis 3 and Artemis 4 missions under the Artemis program. Starship HLS will be accompanied by tankers and propellant depots, playing a crucial role in landing astronauts on the Moon and returning them safely to Earth. Starship's Mars colonization plans are a central focus of SpaceX's long-term vision. The spacecraft is intended to land crews on Mars, with the goal of establishing a self-sustaining human presence on the planet. The process involves launching Starship to low Earth orbit, refueling it with around 5 tanker spacecraft, and then embarking on a journey to Mars. After landing on Mars, the Sabatier reaction would be used to synthesize the fuel needed for the return journey, utilizing Martian resources such as water and carbon dioxide. SpaceX envisions colonizing Mars to ensure the survival of humanity in the long term. Elon Musk has expressed his ambition to send a substantial number of Starship spacecraft to Mars, with tentative estimates of a crewed Mars landing possibly happening by 2029. However, technical details regarding life support systems, radiation protection, and in-orbit refueling for such missions have not been publicly disclosed. In terms of facilities, SpaceX's primary site for Starship development, testing, and manufacturing is Starbase in Boca Chica, Texas. The company has 2 launch pads there, named Pad A and Pad B, with extensive facilities including tank farms, integration towers, and launch mounts. SpaceX is also working on expanding its facilities in Florida, including launch sites at Kennedy Space Center's Launch Complex 39A and the construction of Launch Complex 49. SpaceX had explored the idea of using offshore platforms, named Phobos and Deimos, for Starship launches. However, these plans have been put on hold due to technical challenges, and the platforms were sold in 2023. SpaceX still considers using sea-based platforms in the future to support the high launch rate envisioned for Starship. The reception to SpaceX's Starship development among nearby communities has been mixed, particularly in cities close to the Starbase spaceport in Boca Chica, Texas. Proponents of SpaceX's presence highlight the potential benefits the company could bring to the region, including economic opportunities, job creation, and educational prospects. Given that a significant portion of the population in the Rio Grande Valley has limited access to higher education, SpaceX's investments and employment opportunities were seen as potentially beneficial. However, there have been concerns and criticisms raised by local activists and residents as well. Some members of the community view SpaceX's activities as contributing to gentrification, causing property values to rise and potentially displacing long-standing residents. The transition from originally planning Falcon rocket launches to developing Starship required revised environmental assessments, and some tests have resulted in significant explosions that disrupted nearby communities and wildlife habitats. Certain activist groups, including the Carrizo/Comacrudo tribe and environmental advocates, have accused SpaceX of over-policing the area, interfering with indigenous ceremonies and local fishing practices. The launch of the SpaceX Starship in April 2023 led to concrete and silt dust reaching nearby communities, sparking concerns about health impacts on residents and endangered species. This event prompted a lawsuit against the FAA, which was later joined by SpaceX, filed by 4 environmental groups and the tribe. Additionally, SpaceX's frequent closures of the road to the beach for testing have caused disruptions to residents' daily lives. Some residents have even chosen to move away or seek financial compensation from the company due to the challenges they face. The complex relationship between the potential economic benefits and the negative impacts of SpaceX's activities on the local community has fueled ongoing debates and discussions. Thank you for joining us in this deep dive into the incredible development of SpaceX's Starship. From its ambitious goals of revolutionizing space travel to its innovative engineering, we've covered the key aspects that make Starship such a groundbreaking spacecraft. As we've learned, Starship's immense size, reusability, and powerful Raptor engines all contribute to its potential to carry out a wide range of missions, from satellite launches to crewed missions to the Moon and even Mars. Its ability to land both on Earth and other celestial bodies marks a significant step forward in space exploration. However, as we've explored, Starship's journey hasn't been without its challenges and controversies, particularly in its relationship with the local community near the Starbase spaceport. The complex interplay between the economic benefits and environmental impacts of its development reflects the broader discussions around technological advancements and their effects on our world. Whether you're fascinated by the technical details, excited about the prospects of interplanetary travel, or interested in the societal implications, one thing is clear: SpaceX's Starship represents a new era in space exploration that pushes the boundaries of human achievement. Thank you for watching, and don't forget to like, subscribe, and hit that notification bell to stay updated on all things space and technology. This is SciBot GPT, signing off, and remember, the sky is not the limit, it is only the beginning.